What a transmission electron microscope does is it takes electrons and accelerates them very, very fast, and it shoots them through a very thin sample of material. And then it sort of casts a shadow down onto a screen, and on that shadow you can see different atoms lined up in rows and columns for crystalline materials. Why is this important? Well, as I mentioned before, with nanotechnology we're making components, we're making these very tiny components, and how we get them to assemble means as much to the actual device as what they're made out of. And so another interesting thing about nanotechnology is sometimes the size or the shape of the device means more than what it's actually made out of. So you can take gold and you can have a big chunk of gold, and it has certain properties based upon being a big chunk of gold. And you can jam something else onto it, and where those two materials meet will form an interface. And in the big scheme of things, that interface is controlled by physics, and it will only be a few atoms mixing together of the two materials. And if you've got a big chunk of A and a big chunk of B, that interface doesn't really mean that much. But when you start taking those away and you only have a few hundred atoms of each, and you jam them together and half of those atoms now become the interface, that interface controls the property of the whole thing. And with these tools, with this microscope, we can go down and investigate those interfaces on the atomic level. Now, an interesting thing to continue on with that idea, if you take a chunk of gold and you've got a big chunk, well, if you take a few hundred atoms of gold, all of a sudden it starts to act differently. It turns red. And if you move it down and you have just a few dozen atoms, it turns blue. So it can change. And the reason is normally in gold, if we were all lined up like gold atoms, we would be lined up in rows and columns, and we'd be a certain distance apart. And we'd all be the same. I could look over at my neighbors, and my neighbors would all be in the same place, and I would be comfortable in that matrix of where we are. But when we start moving down into nanomaterials, say we've got a nanosphere of gold, we've only got a few hundred atoms, and now when I look over a few layers and I don't have any friends there because it's an edge. The analogy is, think if you're in a stadium with 20,000 people and you're in the middle of this and somebody lets a lion out on the outside. You're probably not too worried if you're in the middle of this pack. But if you're out on the edge, you're worried. Now if there's only 20 of you, you're all pretty worried, right? That's the idea. That's one of the concepts of nanotechnology. As we move smaller in dimension and we get down to a limited number of atoms, the property of the atoms change, and the property of the overall system will change. And we can come in here and investigate those properties at the atomic level. Now, we've got 6 microscopes in this room in total, and they each have a little bit different function. And sometimes I like to talk about what those are because you guys not being in this field, you probably think it's all science fiction, and I can't really do that with these tools. But for example, each one of these tools has a device on it that allows us to go down and taste what the material is. So we can shine a beam of electrons on, it will produce X-rays that come out, and those X-rays are characteristic of what that material is. So I can shine it on a small group of atoms, and I can tell you if they're copper or steel or carbon or whatnot. We can pick up inside this one, this one over here, with a little tiny robot arm, we can pick up a nanowire and we can place it down exactly where we want it. Not only that, we can then weld it in place. So if we want to put that in and make a device, we can put that nanowire down, weld it in place, and if it's too long, we can trim the end of it off also. Any questions about the electron microscopes?
I have a question about the new $4 million one. How long does it take to install that? And how many people have to work on that installation?
Do you want the answer from the company that sold it to us, or do you want the real answer?
The real answer, both, yeah.
Nominally it takes about 8 weeks to install, and they like to do it with a crew of 2. We've accelerated our schedule, and we have 3 or 4 working on this as a team, and we're trying to do it in less than 6 weeks. This room, let me talk about this room a little bit because it's quite a feat. This is the only room like this in the whole region. This room has to be designed for 3 key features. One, the environment of the microscopes is highly specialized. You notice that I'm in here practically shouting and you don't hear my voice coming back, right? And I don't have any covering up on this. That's because I want all of these different surfaces to bounce the sound around so I don't get echoes. So it's very quiet in here. You can hear some pumps that are in a closet over there. They're actually pretty quiet. But that's part of this room, is we don't want vibrations. Because if I'm standing next to this and we're looking at it in high resolution and I'm talking like this, we'll see it vibrating on the screen. That's how sensitive it is. The floor vibrations are important, and you'll notice that the floor is covered with aluminum. We're in the process of covering all of the walls and the ceiling with this aluminum plate. And that's to shield this room from electromagnetic force from power cables and whatnot that are around the area. So we've got the environment that we have to worry about. The second part is we teach classes. I had a boss some years ago. He said, Mike, you can have nice labs or people can use them. One or the other. And what we want is for people to use our labs. We want people to come in and learn how to use the equipment and sit down and drive the microscopes.